All right, now ready for the second part of chapter 6. Got one more thing to do with the prices, and then we'll move on to unemployment. So in the book, they have this labeled as 6-1D, converting dollars from one year to another. Alright, so again, this chapter is broken into the prices section and then the unemployment section, and this is the tail end of the prices section. And what I'm gonna do right now is a little different from the way the book organizes it. So I would recommend following along with the video, just because I think this is a little easier way to solve for something that the book also addresses. And so here's the basic idea. This is a real-world example of something that actually happened to me when I was in grad school in 2011. I was making $17,500 a year to teach a couple of classes and help with research. And I was talking to my dad, and his first job, his first real job, he got paid $12,000. And so my immediate thought was, wow, I'm making more as a grad student than you did back in 1978. But then I realized I need to consider inflation. So we can use CPI to directly compare these values and figure out what these would be worth. In other words, we can take this $12,000 and say, what would that be worth in 2011? Or we could take this amount in 2011 and say, what would that be worth in 1978? Okay? And by doing that, we could answer the question, who earned a higher real salary? Okay? This is a good time to bring up this term here, real. When something is real, that means adjusted for inflation. And that's something we'll talk about a lot in this class is, values that are real. We'll talk about real GDP, for example, which is inflation-adjusted GDP. If it's not real, it's nominal. So nominal means not adjusted for inflation. So if I just say, I was earning $17,500 in 2011, that's nominal. It's not adjusted for inflation. If we wanted to adjust for inflation, then we could compare these two values. Okay? So that's real and nominal, a couple of important terms there. All right, so who earned a higher real salary? Let me just give myself more room. I'm just going to write down the same stuff that I just had up here, just to give myself more room. Okay, so to solve for this, there's a formula we can use, and here's the generic way the formula works, okay? So the amount in year A, and I got to explain what these mean. The amount in year A equals the amount in year B times the CPI in year A divided by the CPI in year B. And the challenge comes, and for these types of questions, the challenge comes in setting this up correctly. Okay? So what I'm going to try to do is I want to take my dad's salary here, this $12,000, and I want to figure out what that would be worth in 2011 dollars, okay? The logic here being that $12,000 in 1978 could probably buy a lot more in 1978 than it could in 2011. So I need to do some adjustments, okay? So what I need to do is I need to solve for an amount in 2011. The left-hand side of this equation can always be set up to be the answer, okay? And then on the right-hand side of the equation should be everything that I'm given. So what I know is the amount in 1978. Okay? And here are the CPIs I need to use. I need to use the CPI in 2011 divided by the CPI in 1978. So the numerator here always aligns with the answer. Okay? I'm trying to solve for 2011, so that's going to go in the numerator here and the solution over here. Okay? And again, what I'm trying to do is I'm trying to figure out how much would the amount in 1978, this $12,000, be worth in 2011 dollars. Okay? So now I can plug in these values here. All right, so I take that, take that 12,000 and I multiply it times the ratio of these CPIs. All right, so I went online and I looked this up, okay? And on a question like this, I'm just going to have to give you the CPIs, okay? So I went online and looked these up, and here are my CPIs for these years using, I think, I believe it was like 1990 as the base year, okay? So here are the CPIs. What this basically means is this CPI here is about almost 4 times larger, or 3.5 times larger. So prices were about 3.5 times larger in 2011, okay? So what this is basically doing is saying if prices were 3.5 times higher in 2011, then we need to multiply that 3.5 times 12,000 to see how much it would be worth, okay? So I can solve for this, and what I think you'll get is about $41,392.64, okay? And these are always just estimates, meaning this is not literally how much it would be worth, because everything is really based on estimates. If you think about calculating CPI, it's all really based on estimates, okay? And so these are estimates as well. And what I want you to think about is, how do you interpret this answer? What does this answer mean? Well, what this means is earning 12 grand in 1978 would mean you have the same level of wealth or the same buying power as earning earning this amount in 2011. In other words, in real terms, this right here, $12,000 in 1978, is equal exactly to having $41,392.64 in 2011. Okay? So that's one way we can think about this, and then we can compare, and you see that my dad's salary was actually substantially more than mine once accounting for inflation. Okay? So let's do one more example before we move on. So let me give you the CPI for a few different years here. And this is an example I like to use in class because I think it's something you might actually be able to take advantage of. So let's imagine that those are the CPIs, and in 2019, let's say you guys graduate in 2019 and you earn a nominal salary of, let's say, $42,000. Well, then the question would be, in 2021, what would you need to earn to have the same real salary? Okay? So in other words, if you're going to earn 42 grand in 2019, what would you need to earn in 2021 to have the same real income? Okay? And so this is a question that the challenge is setting up that equation correctly. Okay, and I like to write the equation out every time. It just makes it easier for me to realize what I'm doing. I've noticed that when I was originally learning this, I'd kind of just try to jump to the answer. Sometimes I'd make some mistakes, but if I write the equation out, I don't really ever seem to make any mistakes. It just makes things a lot more simple. So here's what I'm trying to solve for. Okay, And what I'm going to do is I'm going to write out my generic formula and leave out the key details here. Okay, here's kind of like the skeleton of my formula. And now I need to figure out what goes where. Okay, so the first thing I'm trying to do is figure out what am I really trying to solve for here. And what I'm trying to solve for is 2021. What would I need to earn in 2021? Okay, so that goes here, right? After all, I don't know that. That's what I'm solving for because I don't know it. On the right-hand side of the equation, what I know is 42,000. That's the amount that I earned in 2019. Okay? And then the last thing I need to do is plug in these CPIs. And the CPI for the year I'm solving for always goes up top. And the CPI for the year that I am given always goes on bottom. And what this basically doing is figuring out the ratio of prices to kind of make this adjustment that I need to make. All right. Now, this question suddenly just looks real easy. Just plug in the values, right? I've got the values, so this is super easy, okay? In fact, I already kind of jumped ahead there. What I meant to write here was 2019, okay? So that's that $42,000 there. So plugging these in, 42,000 times the ratio of CPIs, like that. Okay. Notice it's only those 2 year CPIs that you need, okay? So part of the difficulty is making sure you use the right information from up here. So just putting this in my calculator here and seeing what I get. And what I get is 43,357.21 cents. Part of the reason I like to teach this is because I think this is potentially pretty useful, and I've had some students in the past that have gone to their boss and asked for a raise based on this logic, okay? So what often happens if you join a company is maybe your salary doesn't go up very quickly. So maybe in 2019 you joined the company for 42 grand, and in 2021 you're still earning 42 grand. This would be a good time to ask for a raise, and a good way to ask for a raise is just to walk in and say, look, I did the calculation. This is the amount that I should be getting paid if I'm earning exactly the same amount in real terms. I've been here 2 years as an employee. I certainly haven't become a worse employee, but what you're doing is paying me less than when I began. So I would like for you to pay me at least the same amount that I was paid 2 years ago. That's a pretty compelling argument that I think most bosses would be sympathetic to. Most whoever it is that determines your salary would probably be sympathetic to. Okay, so again, to interpret this answer, what this means is 42,000 in 2019 has exactly the same value as this in 2021. Okay, that's what we can do with that. On the quiz or on the exam, to make this question more challenging if I wanted to, I could first give you the basket, the stuff to solve for basket price, then you'd have to solve for CPI, and then you could answer these questions. So these questions can get pretty tough if I wanted them to. I'll have to decide how hard I want to get. Okay, so that takes us past part 1 and moves us up to part 2. This is chapter 6, part 2 now. And this is the focus on unemployment and the labor market in general. And so to get at this concept, to kind of introduce it here, let me give you some possible labor situations of what you might be considered. You might be considered employed, okay? And it might be simple just to think, well, employed, we all know what it means to be employed. But do we know what it means to be employed? For example, if I am working for an hour a week, maybe I give a swim lesson 1 hour a week. Am I employed according to the government? And the answer is yes. Employed simply means that you did any work for labor. Any work for pay, I should say, during a given week. Okay, and what we're trying to do in this chapter is think about employment and think about how things like the unemployment rate are calculated. And you guys, you've all seen unemployment rates, right? So you understand that this is something that is discussed a lot. The unemployment rate is probably the most talked about employment statistic, maybe other than the stock market, okay? Unemployment is discussed a lot. So being employed, what you can see right away is easy. When they're calculating these things, what they'll do is they'll survey people and they'll ask them, last week, did you work? Did you get paid to work? If they say yes, well, they're employed automatically, okay? The other way to be employed, so that's one. A second way to be employed is to do at least 15 hours of unpaid work in essentially a family business. All right, 15 hours of unpaid work in a family business. So, let's say, for example, your uncle owns a landscaping business, and every summer you go work with him Monday through Thursday and help out. That's considered employed. The logic is that people who are doing this type of work maybe aren't getting paid cash, but maybe they're getting a place to live, food, that sort of thing, right? Like you're working for room and board. So we call that employed as well. So all you have to do is fall into one of those two categories to be considered employed. Other things you can be considered. You can be unemployed. All right. And that basically means that you are not employed, but it means more than just that. Okay. So for example, I have a 2-year-old daughter. She's not unemployed. All right, she doesn't have a job, but she's not unemployed. Okay, so to be unemployed, you must have fit the following criteria. You must be within a certain age group. I can't remember off the top of my head what it is, something like 18 to 65. So you fit into a group that we might consider eligible for work. You are not in the military or prison or a mental institution or anything like that. All right, it kind of sounds funny to lump military in with these two. The basic belief here, though, is that if you're in a mental institution, maybe you're not capable to work. If you're in prison, there's no way for you to work. And if you're in military, yeah, you're working, but let's throw that out because it's kind of different, right? So if we had a major war, all of a sudden a lot of people would probably join the military. Then it looked like the economy is doing a lot better. But that's not really the point, right? So the military is just kept separate. Let's just not worry about the military because the military's employment rate, if you will, doesn't go up and down with the economy. It's based on other things, okay? So you must be within a certain age group. You must be not in the military, prison, mental institution. I think not a full-time student. I believe that's in there. Okay, so basically there's just these restrictions that count you out and make you not eligible to be considered unemployed. You must not work for pay at all. In other words, you must not be employed. You must not fall into one of these categories up here. And that means at all, right? Even if you do that one swim lesson, you're employed at that point. So you can't be both employed and unemployed. And then the fourth one here is you must be making an effort to find a job. So what this basically shows is it's pretty hard to be unemployed. It's easy to be employed. You just need to work, right? Work and get paid for it. Or work at least 15 hours a week and not get paid for it at a family business. But to be unemployed, you have to be within a certain age group, not in prison, not in the military, not anything like that. You can't be making any money, and you have to be trying to find a job. You have to actually be able to show that you're trying to find a job, okay? And that's just the criteria that we have. This fourth one here makes it hard to be considered unemployed, but this makes sense that this should be included, right? If I retire early, let's say I retire at age 55, if we call me unemployed in that case, then when I retire, it makes it look like the economy's bad. It's not the economy's bad, right? If I'm retiring, the economy's probably good. So that's why that needs to be included there to make sure we're counting the right people. So you can be employed, you can be unemployed, you can be eligible to work, but not in the labor force. Eligible to work, but not in the labor force. This is not, doesn't really have a good term to it, okay? So this is kind of just describing the concept. But basically, if you're eligible to work, but not in the labor force, that means you fit the criteria to be considered eligible to work. So you're like, 18 to 65, not in prison, etc. But you are not working and not looking for a job. So this could be the person that retires early, right? That person is not employed or unemployed. If they retire early, they're not employed because they're not working, and they're not unemployed because they're not looking for a job. So these would be the people that are eligible to work but choose not to. The fourth category then is those that are not eligible. Like my 2-year-old daughter, right? She doesn't fit into that age group. People in prison, people in military, that sort of thing. Okay? So that's the possible scenarios you could be in. Part of the reason why I illustrate this point is so you realize when we talk about people that are unemployed, we're focusing on a specific segment of the population. A really big chunk of the population is in this fourth category, right? A lot of people are below the age of 18. A lot of people are in prison. A lot of people are in military. So a lot of the economy is not even discussed in the labor market. All right, and then we've also got a lot here. A lot of people that choose to be stay-at-home parents. Maybe they just don't want to work, so they're not trying to work. Maybe they're retiring early, whatever, right? Maybe they're traveling the country instead of trying to work. So overall, you end up with a lot of people who aren't in this discussion. This is important. We'll come back to this later on, but this is important because when the economy gets really bad, these categories sometimes will expand. Okay, so we have two key variables that we're going to discuss. One is the unemployment rate. And the thing that I've found with the unemployment rate is a lot of students really don't know what it means. A lot of people think that the unemployment rate is the percentage of people who don't have a job, but that is not the case. This is the percentage of the labor force that does not have a job. Okay, and we've got a term within a term here, labor force. So the unemployment rate is the percentage of the labor force that does not have a job, and the labor force includes people that are employed and unemployed only. Okay? The employed and the unemployed only fall into the labor force. Okay, so this is basically looking at the people who we think want to work. The employed people, we know they want to work because they are working. And then the unemployed, we know they want to work because they are looking for a job. So this is all the people that are trying to work. Okay? So what the unemployment rate does is it finds the percentage of the labor market that really is, it finds the percentage of the people who want to work that aren't working. Okay? So the way this looks mathematically is the unemployment rate is the number unemployed divided by the number in the labor force, and remember that's all the employed and unemployed people, times 100 to turn it into a percent. Okay? So for example, if in a small town we've got 400 people unemployed got 16,320 people employed, then the unemployment rate would be 400 divided by these two combined. This is the labor force. All the people that don't have a job but are trying to work, and all the people that really are working. So divide that by 16,320, multiply that times 100, and that gives us the unemployment rate of something. Let's see what we get here. So we get 2.45%, which would be a really good unemployment rate. Really low unemployment rate, I guess would be a better way of saying it. I'm not sure if it's good. We'll have to think about that in a bit. All right, so that's how that's solved. Generally speaking, the lower the better. For the most part, that's certainly the way the popular press and it appears politicians think about this, that generally the lower is the better. Economists are not so sure that's the case. So that's one of the key variables. The other key variable is the labor force participation rate. And this is the percent of the eligible population so take that group of people who are 18 to 65, not in prison, not in military, etc. It's the percent of the eligible population that is not, that is in the labor force. In other words, the percent of the eligible population that is either employed or unemployed. Okay? So to solve for this, the labor force participation rate is equal to the employed plus unemployed, or in other words, the labor force, okay, divided by the eligible population times 100. Simple enough, okay? So for example, let me give you one more example here. I'm going to erase all this so I have some room. Some data that we might have for a given economy is maybe we have 600 people employed, we have 90 people unemployed, we've got an eligible population of 950, and we have a total population of 1,400, okay? I'm making these numbers up, but I'm making them, at least the relative sizes are pretty similar to what you might see for most countries, really. You've got a certain amount employed, a certain amount unemployed, the eligible population, so this includes everybody who's employed, unemployed, or they're in that age group, but not trying to work, right? They're not in the labor force, so somebody who's retiring early. So we've got employed, unemployed, plus people that retire early, stay-at-home parents, that sort of thing. They all fall into the eligible population. And then the total population would include, kids and senior citizens, people in prison, that sort of thing. So from this, we can solve for the unemployment rate, which should be 90 divided by 690 times 100. Okay? It's the unemployed divided by the labor force. Okay, that's the labor force there. And you get about 13%. And then the labor force participation rate would be 690, the labor force. Divide that by the eligible population of 950. And you get 72.6%. Okay? I think I'm going to stop here for this video, so we're going to do 3 parts in Chapter 6. Just trying to make these videos small enough because YouTube does a better job handling them when they're small. So that's how you solve for them. What we'll do in the third part is try to figure out what's a good rate. How do we look at these values, and how do we think about it? This is a long chapter, so hang in there. Hang in there, I guess I should say. Remember, this class, we're doing this in 4 weeks. That's not much time. That's, we've got 4 weeks, so that's 20 days, 3 of them for exams, I guess. So we've got 17 days. So what we're covering here each day is about what we would cover in a week and a half during a regular semester. So we've got to make sure we're covering plenty of material. Okay. Next video will be posted soon.